Everybody, so now that you've been introduced to Knex and some of the wonderful things it can do for you as a query language, we're going to get into creating seeds and migrations using Knex. So one of the greatest benefits of Knex is it makes it easy to, rather than using raw SQL, you can create all of the schema for the tables in your database, and then you can seed those tables with data, which you can then check to make sure that it's in there. Then programmatically, when you are creating like a front end or using Postman with your server and your database, you can then add more data if you have the appropriate routes. We're going to cover some of those routes more tomorrow, but for right now, we're going to focus just on creating the schema, the migrations for our tables, essentially creating the tables in the database and then seeding them with some data. So to practice this, I've created this Knex Seeds and Migrations folder here. I've already set up some scaffolding. So if we look in Atom, we have an app.js file, has a bunch of middleware that we're using, like body parser, which you're familiar with by now. If some of this looks unfamiliar, don't worry about that. We do also have a routes folder. We're using the Express router, so when we make requests to slash or to slash users, we're actually referencing the files in here. Again, don't worry about this part too much right now because we're going to be focusing specifically on seeds and migrations. So now that I do have this basic scaffolding set up, I'm going to need to initialize Knex first by installing it. So let's do npm install -- save, and we're actually going to install Knex. We're going to install PG, which is Postgres, which we need as a dependency for this project. And we're also going to install .env. If you recall, we've used environment variables a little bit in the past, or at least talked about them. And we're generally speaking going to be using .env more for when we're pushing things to production. We're going to be just doing development right here today, but just to get in the habit, it's good to include that .env. And I'm just going to npm install as well in case I have any other dependencies in this project. All right, great. Looks like we're in business right now. So once you have Knex installed, the next command you want to use is knex init. This will create, as you see, a knexfile.js file in your directory. So if we go back over, we look, we see we do have knexfile.js. So this is where you essentially configure Knex to be able to work properly with in your local development environment, and also potentially staging, which is more, I believe, for like QA testing and whatnot. We're not going to worry about that. The two things we're going to be focused on are development and production. And again, for right now, we're really mostly going to be focused on development. So one thing we can do here is we can sort of reconfigure this file. We don't need all this stuff right now. Let's get rid of staging entirely. And we'll keep production. We're going to be running our migrations through the command line, so we actually don't need this stuff either. And we'll get rid of that trailing comma. And actually, you know what? I've got some notes here. I'm just going to copy and paste and then walk through, show you guys kind of how this should look, because the way we're going to be doing it in this course is a little different than this default setup that I had here. So I mentioned the environment variable. This is just a good habit to get into. We're not using the .env just yet, but we eventually are going to, and so we're going to require it in and use the configuration settings there. But let's focus on how this looks right here. So we now have development configuration settings, and we have production configuration settings. We have changed our client to PG for Postgres. Rather than SQLite 3, I think is the default. Same with production, so this would be more when we're pushing to Heroku. We still want to use Postgres. We'll be installing Postgres on Heroku. And then for this connection, we are referencing Postgres. We're going to be running on our local machine, and we need to insert the proper database name here. So for this exercise, I'm going to make a database called pets, or maybe pets test. And then here in production, again, this is not going to be the focus of today's lecture, but we're going to be using, when we do eventually push to production, we're going to be using our environment variables with the .env file, and we'll have a variable in there called database URL. So when we're in production, we want to use that environment variable, and essentially what that environment variable will be the URL of our Heroku database. So again, don't worry too much about that production side right now because we're going to be focused on development today. So make sure to save the file, of course, and then we actually need to create our database. So we've initialized Knex here, but we need to create the DB. So create DB, and we're calling it pets test for now. When we run that command, we should have a pets test database. So if we do psql pets test, we do connect to something. If we describe the table, we have no relations found because we have actually no tables in this database. That's why we have no relations. So we're on the right track here. Now the next thing we need to do is we need to make another folder and another file to kind of hook Knex in properly and configure it a little bit beyond what we've done here. So the way we're going to do that, we need to get out of our database, and we'll make dir called db, short for database. Let's change directory into it, and then we can create a file called knex.js. You can call this file whatever you want. The convention we're going to be using in our course is Knex.js. Okay, great. Once we have that created, I'm just going to go back up to the main folder, and I am going to slide over to Atom, and let's take a look in here. So again, in the interest of saving a little bit of time, I'm going to copy and paste some code, and then we'll walk through it together. So essentially what we're doing here is we're setting up an environment for Knex to be working with, and we're setting up some configuration. With the configuration is what we just set up here for our development environment, for our production environment, letting Knex know what type of database we're using, letting them know where that database can be found. So again, in development, that's going to be on our local machine. When we deploy, it's going to be living on Heroku, or elsewhere. If you deploy elsewhere, we'll mostly be using Heroku. So this Knex.js file in the DB folder was sort of configuring all that stuff. So this const environment is set to use an environment variable from the env file, which again, we're not using right now. I just want to mention it. Or, because we've got double pipes, or development. So if there is no node environment variable here that's specified in our .env file, then just use development, essentially is what this is saying. And for configuration, take a look one folder up, or one directory up, and take a look at the Knex file JS file, and then invoke the environment there. So use the Knex.js file, KnexFile.js, excuse me, use the development environment for right now. All right, wonderful. So now that we kind of have things wired up properly, we can move on to actually making migrations. So once again, migrations are essentially creating the tables in the database. You guys have gotten some practice doing this with raw SQL. Now we're going to learn how to do it the Knex way. So if we go back to our terminal, there's some Knex commands we can use in the CLI to essentially generate these migration files for us. So I'm going to clear this out so it's a little easier to read. And the command that we want to use is knex migrate make : make. And then after this command, don't just run it without putting anything afterwards. You need to specify the name of the migration file you want to make. The convention I like to use is the number of which migration it is and the name of the table that we're going to be creating. So for this one, in this database, we're going to do two tables. We're going to have owners and we're going to have pets. So for this migration, for this table, I'm going to call it o1_owner. Now for the migrations, you don't technically have to specify a number here because, as you'll see when we go back over to Atom, when you create a migration, well, first of all, it says created migration and it lets you know what folder it's in. So if we go over to Atom, we now have this migrations folder, and inside of it, we have a migration file. It's a JavaScript file, as you can see. Right now, there's not a whole lot in it. I do want to mention, if you look at the text here, this is actually a date time signifier. So for migrations, as you create them, they have this date time that precedes whatever you've named it. So they will always kind of be sequential. Still, I find it to be good practice to actually number your migrations. So that's up to you how you want to do it. I think it just makes it clearer in my head to start with the first table I want to migrate and then move up from there. So if we go back over and we look at this file, right now it's fairly empty, but essentially what we have this exports up function and we have an exports down function. And essentially what these are is exports up is going to be when we need to create this table. We are going to be able to list out, we're going to be able to create the table, name it, and then we're going to be able to specify all of the fields, if you recall the ERDs, so essentially all of the columns that are going to go into this table. That's what's going to go into our exports up function. And then in the exports down function is going to specify what should happen if we need to actually remove that table. When you migrate, if everything goes well, you kind of just migrate sort of sequentially. You create those tables, you build up your database. However, sometimes things can go wrong and you do actually need to roll back your migrations. That's where this exports down function comes in. It lets Knex know that if we do need to kind of step backwards in our migration workflow, this is sort of the function to execute if we do need to sort of go backwards. So the up function is going to be more complicated for sure. The exports down function is essentially just going to say, find this table and just drop it, drop table. All right, so as we go to create our owners now, the first thing that you may notice is that we are using promises here. So we're using Knex and we're using promise. Knex functions uses a lot of promises, so you're going to see maybe some more return statements than you're used to. Just know that Knex does some things a little bit asynchronously, so we do need promises. Again, this is all sort of generated for you, but I just want to point it out so that you keep in mind that we're going to be using promises. So the first line here, we need to create the actual table itself. So we want to return Knex.schema .create table, .create table, and then that's going to be it's a function or a method, and the first thing we want to specify as an argument for this function is the name of the table itself. So following our singular naming convention rather than pluralizing, even though this is going to be a table full of owners, we're going to call the table owner. And then the second argument that this function takes is another function itself, a higher order function. Takes one argument as table. As you can see, I'm using some ES6 syntax here. And what goes inside of here now is going to be the actual fields inside of our table. So the first one you want to insert is table.increments. So this is a method that we have available to us with Knex. All of your fields that you create here are going to start with table. So table.increments, this is essentially creating a primary key ID. All right, sorry about this. I'm going to turn these notifications off. So this table.increments, you'll probably be starting every table that you make with this, because this is going to initialize primary key sequence. It's going to start with 1, and it's going to just automatically increment from there. So every time another entry is created in this table, it will automatically auto-increment the next number. So we'll start with ID 1, then we'll move to 2, 3, 4, etc., etc., etc. So this table.increments is super powerful. Just remember that that's pretty much always going to be what comes first, so we can create a primary key ID to uniquely identify everything in this table. The next thing we're going to do table.text. So the kind of general convention is you write out table, and then the next thing that you're passing through is going to be the type of data that this field is going to contain. So I want my owners to have a name, so we'll do table.text. If we were doing an integer or something else, you can look at the Knex docs to see all the different kinds of data you can insert. This is part of why when we're doing our ERDs, we practice specifying what kind of data we need in that right column. So table.text name is going to be this field, and then we're going to add a not nullable constraint here. So by default, Knex does make all fields, unless you specify otherwise, nullable. So that essentially means that they can have no data in them. So the data in that for that record in that field can be null. For this particular database, I do want all of my owners to at least have a name so I can identify them a little bit. So, but that takes care of the name field. We'll move on. The next field I want to create is going to be an email field. So that's going to be text as well, and then we'll call it email. I also want this field to be not nullable, so we'll chain that method. And then in addition, I want to make this table, or excuse me, this field unique. So you can add a unique flag here, and this will make it so that no email in your database, or in this table at least, can be the same as any other. It can be a nice way to uniquely identify users. And if we had multiple users in the database with the same email, that'd probably be pretty odd and might create some data inconsistencies. So I mostly wanted to show you guys that you can use unique here. So our next field is going to be a date. I want to track the date that this user was added into the database, or this owner was added into the database. So we'll do date created. Also going to make that not nullable. And we'll do one more field. We'll do another text field that will be a little biography, or a little bio of the owner. So a little bit more description about them. That looks pretty good for my owner table in terms of creating it and spinning it up. Again, these are all columns or fields in the table. So we're just designing the schema right now. We're not actually adding any data. And then for the down function, the only thing we're going to return here is essentially dropping the table. So the way you do that, you do knex.schema.drop table if exists. It's a little wordy, but it's very descriptive. So if this table exists in the database and we're rolling back our migrations, just find this table and delete it. So you got to make sure that when you're creating, for your up and your down, that your create table name matches your drop table name. Otherwise, those functions are not going to work properly. Or if you if you have a different one when you've created it, it will not be able to find it and then drop it when you roll back that migration. But again, the only thing you need in this down is, generally speaking, going to be one line here to find the table, and if it exists, just drop it if we're rolling back our migrations. All right, great. That looks pretty good. Now, if we slide over to our back over to our terminal, the command to actually run this migration is knex migrate latest. So this command will only run the any migrations that you have not yet run. So we see we're using our development environment as we specified in our connection file, our Knex.js. In development, use Postgres, use just my local computer and the pets, specifically the pets test database. We specified where to find that connection in this file, and then we ran this migration. Looks like it ran well. If we psql into the database and we describe the tables, we see now we have an owner table. If we describe specifically owner, we now see we have an ID column. It's an integer. So this is what came from that table.increments code right here. So we have an ID. We have a name, we have an email, date created, which is a date, bio. So we've got an integer, we've got some text fields, and we've got a date field. And we have some not null constraints here. We did make the bio, we didn't specify for bio not nullable, so bio can be nulled. And then we have essentially identified that we have a primary key and we have the unique constraint on email. So that gives us a bunch of information if we /d the table. If we try to select information from the table right now, though, from owner, whoops, semicolon, we see we have all of the fields, but we don't have any data in it because all we've done so far is migrate. We haven't actually seeded or created any data. So all's going well so far. So let's get out of there. I'm going to clear my terminal so it's a little easier to read. And let's make another migration. So we'll do Knex migrate make, and I'm going to again specify with numbers which migration this is. We'll do O2, and we'll call this one pet, since this will be the name of the pet table in our database. Again, we're using our development environment. We have our migration created. As you can see, it's coming right after owner. And we have now this kind of this familiar structure that we're seeing. And for this table, we are going to have different fields. But again, we're going to start with a auto-incrementing ID. So if we do, we'll do table.increments and invoke, oh wait, sorry, first we need to actually create the table. Like that. So we'll do return Knex.schema.create table, and this table is going to be called pet, and the second argument that this is going to take here is a function with the argument of table. It's a higher order function, and now in here is where we actually specify the fields for this table. So we've got table.increments for our primary key ID. We'll do table.text and we'll do name, so the name of the pet. And let's make that one not nullable because it kind of makes sense if we're thinking about this database to at least have the name of the pet in here. So there's not going to necessarily be a ton of data in this particular table for this example, but we do want a name and we do want that data to be there and make it so that's not null. Next one I'm going to do, we'll do an integer and let's track the age of the pets. Now, we're not going to specify not nullable for this one. It'll be okay if we don't know the age of a particular pet. As long as we have their name, I think we'll be okay. And we're going to do another field here that's an integer, and this is a little wonky looking. This is going to be our foreign key designation. So we need to tie pets to owners. And so if you think of this as like maybe a one-to-many relationship, one owner can have many pets. So in the pet table, we're going to need to have a foreign key that identifies which owner this pet belongs to. So that's what we're going to be doing here. It's going to be an integer. It's not serial. It's not auto-incrementing like primary key. It's just going to be a number that represents the primary key of the owner in the owner table. And so as we've been practicing in our EIDs, we're going to call this one owner_ID. This field will be owner_ID to let us know that this is essentially a foreign key with this _ID. This is the ID of an owner. This ID lives in another table if we want to get data about it. And then to truly make it a foreign key, we need to add in this references. And here it's kind of like when you're doing your raw SQL joins, we need to specify how these are connected. So we have references, owner.id. So again, as we've been practicing, owner_ID for the foreign key, owner.id because we want to actually be accessing the owner table and referencing just the ID field in that table. And then to fully complete this, we add unsigned, and then we also chain on delete, open that up, and add in cascade. So this probably looks a little weird and maybe a little overwhelming. Don't worry about it too much. Essentially, all this is saying is this table, this field is a reference to the owner ID. It's a foreign key referencing the owner ID, which is a primary key in another table. And if this field gets deleted, cascade that delete. So essentially delete data from elsewhere in the database, because we can't have sort of hanging data. We talked about ACID compliance, so this is sort of all or none. We cannot properly remove information from our database unless we remove other places that it's attached. So if someone were to delete an owner, we would also delete this reference. And you guys can look into that more in the documentation. I know this whole line is a little bit overwhelming, but just roll with it, roll with the convention for now, and understand that if you're seeing this kind of syntax, that you're dealing with a foreign key relationship. All right, great, looks good. And then for our exports.down, we'll return Knex.schema.drop table if exists, and we'll specify the pet table. And once again, we'll make sure that this lines up with our created table. Create, drop, great, looks good. So let's go back to our terminal and let's run this migration. So Knex migrate latest. Again, since we've already run our owner table migration, it's just going to run this pet table migration. Beautiful. Batch 2 run, one migration has been run. It ran the pet migration that we just created. So now if we psql into our pets test database and we describe our tables, we now have owner and we have pet. Beautiful. And if we d the pet table, we see we have 4 columns. We have the ID, which is an integer. It's a primary key. We have our name, text, not nullable, as the primary key is. We have an age, which is nullable. We have an owner ID, and we see pSQL or Postgres has specified foreign key constraints here. So we see pet owner ID, so that's this field, is a foreign key, and it references owner ID. And then we have this on delete cascade thing, which again keeps our database ACID compliant. Beautiful. So our migrations have been run. We're just for the sake of this exercise going to do 2 migrations, 2 tables in this database. Now that we have our migrations working, now it's time to actually make seeds. So once your migrations are complete, we can use another Knex command. We can do Knex seed make, and again we need to specify the name of the seed we want to create. Now when you're doing seeds, it actually is important to specify like numeric order. Migrations doesn't matter so much because they do this date time thing as sort of the beginning of the name of the file. Seed files do not do that. So you need your seeds to be run in the correct order, particularly because of primary key and foreign key constraints. So if we try to create our pet data before we create our owner data, pets is going to be trying to reference a table through that foreign key that doesn't exist. So we're going to run into an error. So we need to number properly, and we need to make sure that we do owner first. We can call it owners. So great, we've created a seed file. Now in addition to our migrations file, we have a seed file. So I'm going to close the migrations down for now, close the DB folder down. We'll focus right in on seeds. So if we take a look at the seed file, this is probably going to look a little bit odd. We're going to actually design our seeds a little bit differently. It does look kind of similar though to the migrations file. We have this exports.seed. It's a function, returns a promise. Again, most of the stuff we do with migrations and seeds is, and with Knex in general, is going to be using promises. So you'll be seeing that a lot. The first thing that we want to do when we run our seeds is Actually, you know what? I have some notes here. In the interest in saving some time, I'm going to copy paste and then we'll walk through it together because we are going to be structuring things a little bit different than doing these insert statements sort of one by one. It's the way I prefer to do it. There are other ways. Berto may do it differently, but for right now, I want to show you guys sort of how I prefer to do it. So let me pull some data about the owners. So here we go. So this exports.seed is going to remain the same, and we are going to delete existing entries, but we're going to do it a little bit differently. So let's walk through this together. First thing I want to focus on is this delete existing entries thing. So what this is doing, this is a raw SQL statement. So you can write any raw SQL you want with Knex. So we're returning knex.raw. So first thing we do when we run this seed file is run this raw SQL command. And what this is doing is saying access the owner table, delete data in there, and then alter the ID sequence. So essentially, because we're going to seed 2 entries in this table, we will be specifying their IDs in our seeds. But then once the seed data is in there, we want the ID sequence to restart with 3. So we'll seed 2, and then as more data gets added dynamically through routing and stuff, we'll restart with 3. So if you have 10 seeds in here, you want to change this to restart with 11. If you have just 1, restart with 2, etc., etc. And then you also really need to make sure that you're deleting from the right table, and that when you alter the sequence, you get the name of the table correct here as well. All right, let's walk through this real quick. So run this raw SQL command when this seed file is run, and then let's execute an anonymous function. The first thing I'm doing in this function, let's break it down with some spacing. First thing I'm doing, I'm just declaring a variable. I'm creating an owners variable that's an array of objects. It's going to have 2 objects in it, and each object has the requisite information about that owner. So we have an ID, we have a username, we have an email, we have a date created, which is just a new date. So whenever this seed is run, that'll be the date. And we have a short little bio. We have the same thing for our second user. We need our database to be ACID compliant. So we need all of these fields to be the same. And we need all of these fields to match the fields that we've created in our migration. So we have our ID, name, email, date created, and bio. So they match up perfectly. And case sensitivity does matter, so be mindful of that. And then, so this is just a variable declaration, just a typical sort of array of objects. You guys have seen this a lot before. And then all at once, let's insert them. So access the owner table with Knex owner, and then insert owners. So you need to make sure your variable declaration matches up with what you're trying to insert. All we're inserting is this array of objects. Knex knows what to do with it, essentially. So that looks pretty good. Your seeds, unlike migrations, do run all at once. So migrations, when you do migrate latest, it just runs the migrations that you haven't already run. Seeds will run all at once. It's up to you if you want to create all the seeds and then run them all at the same time, all the seed files. I personally like to run them sort of as I go, just in case anything goes wrong. Then I can kind of debug in the moment rather than creating, say, 5 seed files if I have 5 tables in my database, and then having to maybe run back a little bit. So I'm just going to run them after each time we do it, but know that it's running both files each time. Oh, column username of relation owner does not exist. Let's take a look at this. So we have username here, but in our migration, it's just name. So if you do hit errors, you do get pretty good debug info. So the seed did not run. Again, this is part of why I like to do them as one at a time as I go. So I've run into an error, and let's just address it right away. So we go in here, instead of username, let's change this to name. We save our file. All we have to do is run that command again, Knex seed : run. Boom, ran one seed file. Our seed data matched up with our schema properly. And so if we psql into pets test and then select star from owner, semicolon, now we actually have data. Awesome. We have our auto-incrementing IDs. They started with 1, they went to 2. We have names, emails, we have our date created, and we have our little bios right here. Beautiful. We're in business. So let's make one more file. We'll do Knex seed make O2. Again, very important for the seeds to specify the number, the order in which you want them to run. Because when we do Knex seed run again, it's actually going to run both files. Or if you had 5, 10 seed files, it'll run them all, and it'll start in the order which you specified. As you can see, there's no date time signifier here, so it's just going to run them essentially in like alphanumeric order. So Knex seed make O2, we'll call this seed file pets. Knex creates the file for us, creates it in our seed folder. It looks very similar right now to the way the other one did at the start. Following the same pattern as I did, delete existing entries, and then insert seeds, rather than inserting an array of objects, kind of like a line at a time here. In the insert statement, I just prefer to store those in a variable first. So I'm going to do the same thing I did with the previous seed file. I'm going to do a little bit of copy paste, and then we'll walk through it. Okay, so again, first line, delete all existing entries. When this seed file is run, delete any existing entries so we're not creating weird duplicated data in our database. Run a raw SQL command, delete from pet, and then alter the pet ID sequence. Again, very important to make sure that this matches up with this, and then restart the ID sequence with 3. Again, it's 3 specifically because I'm only seeding 2 pets here into the database. And as you see here, I do have the user ID, the foreign key constraint, very specifically specified. So I have Fluffy, who's 6 years old. Fluffy belongs to user ID 1. So this matches up with Sam. Fluffy belongs to Sam. Scout is 3. Scout belongs to user ID 2, so that's Alex. You do, when you're inserting your seed data, have to specify these foreign keys. As long as you have them matching up to other seeded data, like where in the table where the primary key lives, you'll be fine. So we couldn't have something like user ID 5 here because that doesn't exist in the database. Very important to note that. You will run into an error. So delete all the existing entries, then pass this anonymous function. First thing we do, we just declare a variable pets. It's an array of objects. It contains all the fields that we need to insert into the database so that we're ACID compliant. And then access the pet table with Knex and insert my pets variable, insert this array of objects. So if everything has gone well here, we can run our seeds again. I'm going to clear out the console so it's a little easier to read. We'll do Knex seed run. Oh, column user ID of relation pet does not exist. Ah, another error. Beautiful. So we have user ID just as we had username. In owners, we had username. We had to adjust that. Our table is not actually called users. It's owner ID. So if we need to change this to owner ID. Beautiful. So now that we have that specified as owner ID, that matches up with the schema that we created. And as you see, Knex does give you pretty good error messages to debug, pretty easy to parse out. Now that we have that taken care of, we can run our seeds again. Boom. And as you see, it has run both files. It ran the O1 owners first, then O2 pets. Very important to have that order correct. If we tried to run pets first, we would run into a kind of a similar error, but it would be a foreign key constraint error. Cannot find owner ID because that table doesn't exist yet. So now that we have both of our tables migrated and seeded, let's get into our database again. Pets test. Let's just DT real quick. We now see we have our owner table, we have our pet table, and we can select star from owner, semicolon. We've got our owners in there. Beautiful. We can select star from pet, semicolon, and excellent. We have our pets in there too. We've got our 2 users. They've got their unique IDs, and we have our 2 animals, our 2 pets, and they are properly connected to through primary key and foreign key relationships to their respective owners. So that about covers migrating and seeding. I encourage you to check out the Knex documentation if you would like to learn more. They've got really good docs. Actually, I think I have some of the documentation open here. Yeah, here's the Knex JS documentation. They have an entire section on migrations, on seed files. They run you through the commands that you're going to need to use, installing Knex, initializing it, how to make migrations, migrating latest, etc. So everything that we just went through is available on the docs, and I will also upload this code to GitHub along with the video in case you guys want to reference it. All right, wonderful. Thanks so much.